Okay, thank you, JJ. Okay, so proxy layer. Why do we need it? So basically, the proxy layer is a set of servers that will work, that works as a middleman between the application and the database tier. So most of the time, what they do is, they route the traffic from the application to the database tier. The point of having a proxy layer basically is that this proxy layer, this layer should detect and handle issues on the database side. So it should detect whether the instance has failed or something, or maybe there was a topology change and there was a failover and there's a new master. So the proxy should basically handle this kind of changes and hide, and first of all, act accordingly. So if the node is down, then the proxy shouldn't route the traffic to it. It should distribute this traffic among the remaining healthy nodes. But also the point here is to hide the complexity of the database layer from the application. So the application just have one handler that connects to the proxy, and that's it. Yes, the proxy does the magic behind the scenes, and the application doesn't have to be aware of all those problems. So HAProxy is, as we just saw, very popular, and also it's also proven tool. The problem with HAProxy, if we're talking about databases, is that it's not database aware. So it doesn't understand the state of the MySQL servers in the backend. It just moves packets. HAProxy can check whether the port is available or not. So you can configure it to look for the 3306 port, for example, and if it's up, it will assume that the database is also up, and it will route the traffic to it. What is good is that HAProxy can do HTTP tests, and those tests are very useful to build more complex logic to actually handle the database states. So the very popular approach is to use read-only variable in MySQL to differentiate master and slaves. And it makes perfect sense, because obviously slave should be read-only because it shouldn't take any writes. On the other hand, master is taking writes, so it should not be read-only. What you can do is you can have a script that's working in the background on each database node, and it checks the state of a node and checks the state of the read-only variable on this node, and store the result in a shared memory for quick access. And then you have another script that's executed as a service via xinetd, for example. This script, listens on a port, on some kind of port. Yes, the xinetd listens on some port. When the connection goes to this port, xinetd triggers a script. The script checks the state, the state of the system of the MySQL from this shared memory where it was stored, and then it returns either 200 HTTP calls, either 200 for OK, service up and running, or for example 503 if the service is down. And then this is something combined with multiple backends in the HAProxy configuration, and this is something we can use to actually implement some kind of logic. Let's say we have, usually we have two backends, one for reads and one for writes. So both of them are going to some different, they're checking the different ports on the database side. We have multiple xinetd services that are listening on those ports, and those services basically returns the codes as needed. So if we're talking about the write backend, then if the read-only variable is equal to 1, if it's read-only is enabled, it's a slave, so it should not be available in a write backend. Therefore, the script will return 503. For the read backend, on the other hand, if the read only is equal to 1, then that's a slave. That's okay. We will return 200. So you can do some kind of logic here to implement this database awareness. What's important to keep in mind, you need to make sure that this read-only variable will be changed only after the old master was stopped. So you don't want to be in a situation where two nodes have the same, I mean, the read-only disabled, because then the HAProxy will detect two masters, and well, it will route the traffic to them, and which may cause the split brain and serious problems with the database data consistency. And what you can do is, I mean, you can use the shutdown script variable in majconfig to a script that you pass to this variable to handle this kind of situation. So yeah, that's definitely something you need to keep an eye on. MaxScale is a new tool. It's a very recent addition to the MySQL ecosystem. It's a MySQL HAProxy, so it understands, the state the MySQL is in. It understands whether the server is a master or it's a slave. It also understands, for Galera cluster, it can understand whether the node is a part of the cluster, or it's joining, or it's serving as a donor, and it can then route the traffic accordingly. What's nice with MaxScale is that it provides read-write splitting. So as we discussed just earlier, for HAProxy you need to have two backends, one for read, one for write. For MaxScale you can push all the traffic to a single port, and MaxScale will split it on its side and routes the traffic accordingly, like writes to the master, reads to the slaves, depending on the logics. It's still a new software. MaxScale is still a new software, and if you think about using it in production, you definitely want to do some detailed testing around it. From what we saw, I mean, it tends to use a significant amount of CPU if we're talking about read-write split. I've seen also it's having issues with memory leaks, where the memory utilization in MaxScale just grow and grow and grow. Some of those bugs were fixed in the recent 1.2 release. In general, it's updated pretty frequently. So every couple of months, I think 2-3 months passed since the last update. So it's updated pretty frequently, and if you run into some blocking bugs, then you probably want to keep an eye on the development process. Maybe those bugs are being worked on. Well, I mean, having a proxy, that's fine, but you have to, I mean, the proxy layer also have to be highly available. So there are a couple of options that we can choose from. For example, we can put a proxy in front of the proxy, so we can proxy the request to the proxy. And it works really nice as long as the proxy that we put in front of the proxy is itself highly available. And this is true for Elastic Load Balancer in Amazon Web Services, where it's a service, you just create it. You can put your proxies as a backend to backend nodes to the ELB, and that's it. The ELB will be automatically, highly available. It will become itself, so you don't have to, you don't have to worry about it. Other option would be to use virtual IP and fail over it between the proxy nodes, using, for example, HAProxy. Also, what you could do is to collocate proxies with the web nodes. So you have the web server with application, and the application connects directly locally to the proxy. I mean, the reasoning behind it is that if the proxy will be down, it's very likely that the server also, the application server will also be down, and then there is not that much impact. The problem here is that you may have multiple proxy nodes in operation, so you need to use some kind of orchestration tools like Ansible, Puppet, Chef, you name it, to maintain the status of those proxies and maintain the configuration. And every approach has pros and cons, obviously. So the ELB, I think, is the easiest one to implement, but it's available in AWS only. Maybe there's some kind of the similar services are available for other cloud providers. I haven't seen them, but it could be there. There's something like that exists also. But in general, it's limited to the to this providers that basically gives you this option to use. Virtual IP, I mean, the problem here is that the only proxy node will be active. So we have an active standby model, and therefore the CPU utilization may be a problem at some point, like with with MaxScale and read-write split on some larger, higher traffic. Collocating proxies allows you to use more of them, but in general, I found the maintaining configuration can become a burden and problematic. Even if you use all those shiny automation orchestration tools, because these tools are also can fail or something, or there can be a human mistake. So it may be a problem when you will just end with 10 proxies, and some of them has different config than the other, which is not fine. Okay, let's talk now a little bit about some common problems that are related to the high availability in MySQL. So global transaction ID is pretty nice way of making the replication easier to manage, but it comes with issues related to the Errant transactions. So Errant transactions are the transactions executed on the slave only, and that were not executed, that they didn't come from the master. Normally, it's not a problem, but with the GTID, all the transactions executed on a given host will be, so I have a slave. Yes, I executed some transactions on it out of just locally, yes. And then the slave become a master at some point because automated failover, because I choose it to be a slave, to be a master or something. And then every slave that will be slaving off this master will ask for those transactions, and the problem will show up when those transactions are in the binary logs. Because let's say I executed it 2-3 months ago. Yes, they're not anymore in the binary logs, and the replication will break. So there are options to, there are some ways to keep it in sync and to monitor those Errant transactions. We covered it in a separate blog post, so feel free to take a look at several lines website in the blog section, and you should easily find the blog post. And the link is, of course, will be in the slides.